Hi everyone, let's jump into scope. We're still looking at functions, but one of the things that keeps on sort of frustrating new programmers is how functions actually work. There's a lot of gotchas along the way. So although even if it seems like it makes sense, and for some of you it may not make sense, but even if it does seem like it makes sense, there's going to be a gotcha along the way that you could be staring at for hours if I don't give you some warning. And part of this is just making sure you have the right sort of mental model for how functions actually work. So I need to look at scope, and we need to look at a little bit of the call stack. Not enough to really deep dive. We could spend entire classes on this thing, but just enough to sort of get your head around some of the concepts, like what are our variable names, where do they live, and where do they die? Because I know for myself at least, I sure as heck didn't have a firm understanding of this as an undergraduate, and then went off in industry and went, oh, that's how that works. I always thought it was magic. So hopefully it will not be magic to you by the end of this lecture. So just to remind you about functions, I like also pointing out this little thing. So I normally use these slides or these two images when I talk about object-oriented development in 2400, BIT 2400. But it still is applicable here, that one of the benefits of having a function is that you have a dedicated thing that does a particular job. So in case you're wondering what the heck I'm showing you here, this right here, this monstrosity of a room, is what my kids leave after they've played for a long period of time. There is no rhyme, there is no reason, there is just a whole bunch of junk on the ground. This is a temporary anomaly for me. This is the 2 weeks, I think, that my sort of workroom was actually clean. So otherwise, it looks exactly like this. They've learned the messiness from me. But in the interim, for the 2 weeks that this was cleaned, this actually sort of makes sense. This is where I keep all my tools. Okay. If you might imagine, I'm not particularly good using those tools, but I have tools. It sort of checks off the man card. I also have a whole bunch of other things in there, including a Lightning McQueen suitcase, which is not mine. Yeah, it's not over. I'm not overly machismo, but I'm very proud of the fact that I have one little minuscule amount of machismo in my life, which is I have some tools. But this is my dedicated area for dealing with anything that needs to be fixed, stripped, screws put in, glued together, whatever the case is. I have a dedicated place. If I want to know where my tools are, I go to where my tools are, right? It is one-stop shopping. That's what you want with a function, that your code is not just any old place, any which way, it gives you some structure and some order to how your code is put together. And so breaking down your functions into meaningful units that actually sort of make sense and do a particular job, it helps you save your sanity, essentially. If you just have a whole bunch of code every which way all over the place, you're 2 months later, when you go to look at this, you're not going to remember why you did this, where things are. You're not going to be able to find things. Organization of your code is actually a critical skill as a programmer. It also, by the way, allows us to reuse our code, which one of the benefits of having a function is I can call the print function and I don't have to redefine the print function 40 different times. I can reuse that code in a whole bunch of different projects. I can, within the same project and across multiple different projects. It allows me to abstract away the very concepts of what I'm doing, right? Print, what does it do? I don't care what I'm printing about. I'm just printing information to the screen. If I'm getting the absolute value of a number, it's just getting the absolute value. I don't care how it's getting there. And it helps me organize my code. Again, input and output statements are the anomaly. Printf statements in your functions and scanf statements are not normal. They are every once in a while you need them, but if you are putting a printf and a scanf in every one of your functions, you're doing it wrong, period. And I will see some of you put this on the exam. Every one of your functions will have a printf and a scanf, and I will just face palm it. Please, data goes in, data goes out. That is not the same as it printing it to the screen or getting the user input. That's abnormal. Okay. So here's our generic sort of scaffolding or structure to our code. Every single one of our C files will look somewhat like this. I will have some kind of file comment, or ideally I should, when I'm not rushing through things, I'll have some kind of file comment saying what the heck this is. This is assignment 1. I am calculating this particular thing, and it is written by David Sprague, right? Something that, because that's what do people do when you go to a web page and you go to do a Google search? Do you jump into the very first web page you see, or do you read what's on the web page, like the title of the page and maybe the little blurb that they have there before you click it? You don't blindly click. You use that information to figure out where you're going. Other programmers or yourself are going to use that information. That's what the comment's for, to save your time. So little comments. It doesn't have to be. It's not a a story. It is not a novel up at the top. It is just meant to be, this is what this thing is for, so that you can find it later, because things get big. Then you're going to include all your include files. This is things like your standard I/O, so how you get your printf statements and the like, or other header files. We're going to look at that when we go to compilation. I will have every function that I am going to use. Ideally, what I want is a one-line little prototype. It is what the function looks like, but instead of having those opening and closing curly braces, I just have a semicolon at the end. That's saying I will define a function named foo or myPrint or whatever the name of my function is. I am going to name it eventually if you need to find it. If you're in main and you want to be able to find it, or one of your functions needs to call it, one of your functions down here need to call it, it knows there's going to be a function here, and I can find out where it's located there later. So what I end up, well, we'll see this in action with the actual code. I will call from one of these functions. It will go up here, and then it will go down to where the actual function is defined. It allows me to have all my functions know where everything is. I'll then throw in my main function below my prototypes, and then I will define all the functions I promised I would be writing. If I forget to define one of these functions, if I just leave the prototype, I get an error. I need every single function I give a prototype for, I have to have a function. They have to have the exact same name, same capitalization, everything. Okay, so here's function 1, function 2, function X. Okay, so here would be an example of it. Please ignore the cout statement in here, but find hypotenuse, find area, name of my two functions. They have a semicolon at the end. So that if I'm in main and I need to call find area, I jump up here and goes, hey, there's a function called find area. Where is that defined? Oh, it's all the way down here. And jump down here. And that's where I find the function. It allows me to, for main, to know where find area is. Otherwise, C blindly compiles a code from top to bottom. It goes from here down, all the way down. It goes top to bottom. It doesn't know about these other functions. If I try and use find hypotenuse in main without this up here, it does not know it's a couple lines below, right? It is sort of, you could consider this foreshadowing. If I do not know that there is going to be a function called find hypotenuse, and I call find hypotenuse here, it does not know what the heck find hypotenuse is. It makes no sense. That's what the prototype is for. It's saying, I will define something named find hypotenuse. So when you call find hypotenuse in main, don't worry, it's somewhere. It's going to be in the file. Okay. So here's my file comment. Here's my include statements, like including the math library using standard I/O. Here are my prototypes, just the top lines, just a single line saying what these things are. Here's my main function. Here is find hypotenuse. Notice there's no printf statement. Notice there's no scanf statement. Here's find area down here. That's all we had for these functions. Every one of my functions I want to declare before I use. I provide a name and arguments. The function itself has a name and it has particular arguments and has something that it returns. It often performs some operation. It might manipulate some data. It does some job. And if you don't know what the job of that function is, it shouldn't be a function, right? You should be able to clearly say what this thing does. It finds the minimum value. Okay, that's a function. If it finds the minimum value and the maximum value and then does this no, that's not a function, right? It should do a particular job. You should know, you should be able to articulate what that particular job is. We can have return values in multiple different ways. One is the right way, if you will, is we can just return a value. This is what our return statement is all about. Like you return the number 2. or you return x times x, for example. Implicitly, there are something called global variables. We'll be getting to those very shortly. And the global, or we can also modify the parameters themselves, and we'll get to that as well. But remember what we talked about last time. If I change when I have these parameters, I make brand new variables, which are my parameters, and then I modify those values. If I modify those values, it doesn't go and change the original data that called my function, right? If I have, what did we call it here? Find hypotenuse. If I change a posit versus, I would assume it was supposed to be opposite, but or adjacent. If I change the variable adjacent, for example, it does not change my actual data. The thing, if I call, where's my find hypotenuse? This value is not changed. If I change adjacent, C adjacent here is not changed. This is a local variable and lives and dies here in find hypotenuse. So it's kind of hard to change the parameters themselves. I could also have global variables, which we'll get to in a second, but they're considered very bad news. It's bad form to use global variables. And some of you will try, and I will scoff at you. Well, I shouldn't scoff at you because you're learning. But it is a thing that new programmers will start doing. They'll think it's perfectly fine. It'll bite them in the ass, and then they'll go, oh, that's why everyone keeps on telling me not to do that. I've done it. Every programmer I know has done it eventually, right? You go, good enough, I'll just make a global variable. And then you go, oh, that's why you don't do it. So let's get to that